Hello, and welcome to the Earth Science Data Systems GIS segment of the NASA Data Made Easy Tools for the Ecological Data Revolution session. To set the stage for today's presentation, we're first going to do a quick introduction to GIS, talk about the most important piece of the puzzle, the data, talk about how we're using GIS to enable data in web services, applications, and interactive stories, highlight distribution platforms to find geospatial content, and link to our community space. Before we dive in, Geographic Information Systems, or GIS, can mean a variety of different things. Broadly speaking, it's a system of many components: visualizations through interactive maps, data based on the location attribution of features represented, spatial analytic functions that focus on identifying trends and patterns across space, and applications which enable tools and services in user-friendly interfaces. Our vision within NASA's Earth Science Data Systems is to support GIS users by encouraging the development of high-value Earth Science data products that are interactive, interoperable, and compliant with primary GIS platforms, and provide the maximum impact for the ever-growing user community. Over the years, we've seen an increase in the adoption and use of GIS at NASA. The American Customer Satisfaction Index has identified GIS programs as the top tools used to work with NASA data, with ArcGIS rated number 1 and QGIS and ENVI not far behind. The ACSI has captured the desire for more data and services, as well as assistance with data conversion and transformation, both of which can be supported through GIS. GIS has become popular among new communities at NASA, such as citizen scientists, cross-domain researchers, geographers, emergency management personnel, as well as interagency partners as climate change becomes a national topic of interest. Most GIS platforms allow for easy integration with other vector and raster features. For example, you can map and overlay industrial sites on top of atmospheric variables, visualize cities and population data on top of surface temperatures, or identify critical areas within flood zones. GIS also contains powerful spatial analytic functions focused on the where component, using the location information contained within datasets to visualize, process, and analyze. Here are some examples of functions available to support analysis on imagery or raster data. As you can see, the possibilities can seem endless. Having the tools readily available in a single platform allows researchers to spend more time on the science and less time trying to figure out what to do and how to do it. Within GIS tools, you can calculate kernel density, create NDVIs, aggregate data, classify bands, calculate slope, and run a variety of mathematical and statistical functions. So let's take a look at some NASA data and GIS clients. First, we'll start with web services. As Jessica showed us earlier, the Oak Ridge National Spatial Data Access tool allows you to query and specify data of interest. You can then grab the OGC web service endpoints located in the bottom right. Once you find the service you're interested in, you can jump into your GIS client. Here we'll go into QGIS. Navigating to the layer menu, you can create a new connection, connect to the service, and add the layers of interest. Once you add the data to the map, the real fun begins. You can change symbology and start adding more data to visualize and combine features in one view. For example, adding a critical species habitat and overlaying the data with urban growth and population data from NASA's CDAC data center. We can do the same thing using Arcgis Pro. You can navigate to the Connections menu, add a new service, connect to the service, and add layers of interest to the map. Similarly, you can then change the symbology and add other data sets of interest. You can even use Arcgis Online, which is a software as a service running off of a web browser. You begin by navigating to the web map and adding a layer where you input the service endpoint and connect to the data. By utilizing the custom parameters, you can specify slices of data. Data is then added to the map to visualize. Within AGOL, you can also search and discover other content to add to the map. For example, Searching the Living Atlas, you can find and add critical habitat areas for the Chinook salmon. You can then compare their habitat against increasing temperatures in the Pacific Northwest over the past 20 years. This is all done without ever downloading or processing data. If you really wanted to dig into the analytic functions, you may prefer to use the data itself. Similar to what was just shown, you first find, and this time download the data you want to analyze, and then add the data to the map for visualization purposes. In here, we're back in QGIS. Next, you can employ the Raster Calculator to identify areas over the threshold for a typical salmon habitat. These areas are shown in red. You can also use the Raster Calculator to compare data from over 20 years to identify differences where areas are getting hotter. Next, we'll perform a similar analysis in Arcgis Pro. Just as before, you first find and download the data you want to analyze, and then add the data to the map for visualization purposes. You can also search the same repository and add other data from the web. Next, you can employ the Raster Calculator to identify areas over the threshold for a typical habitat. Again, these areas are shown in red, and we can see that a few areas overlap with critical habitat. You can also use the Raster Calculator to compare the data from over the 20 years to identify differences and identify where areas are getting hotter. You can also add more data, such as NASA's CDAC Last of the Wild areas, which depict human influences on terrestrial ecosystems, and see overlap with our critical areas. Now, I'm not a scientist or ecologist, so the examples here were primarily visual, but already one could draw a few possible conclusions. That the majority of habitat remains suitable, habitat loss is east and south of Yakima, Washington, areas in the Northeast are actually experiencing hotter annual average temperatures, and critical areas of concern also overlap with identified wild areas in terrestrial ecosystems. And attention should be paid to urban growth and increasing populations that impact those areas. So those were some quick examples just touching the surface of what you can do with using GIS. Our focus now is ensuring our data can be interoperable and make that happen. NASA teams are assessing high-priority data products and primary GIS tools, identifying challenges, enabling data processing, and working on solutions with the end goal of making NASA data GIS ready. This includes intense data processing, building new functions along the process to better enable the data, performing transformations to ensure NASA data can be integrated in order to provide a more complete, usable end product. For some users, downloading and manipulating the raw data is not necessary or feasible. For these users, simply accessing the data to visualize, investigate, or run common analysis is all that's required. To satisfy these user needs, NASA Earth Science has been busy creating Geospatial Web Services, which provide access to a variety of data as an online service in order to avoid data download and processing on the user's end. Also being created are web applications to enable that data and tools in online user-friendly interfaces. And lastly, story maps, which are immersive stories combining text, maps, and other content, all of which are helping to make NASA data more accessible, easier to understand, and use. In addition to each of the 12 data centers' individual geospatial content, the Global Imagery Browse Service, or GIBS, allows users to visually explore the past and present dynamics of our planet through OGC web mapping services. GIBS provide quick access to over 900 satellite imagery products, covering every part of the world. Most imagery is updated daily and available within a few hours after a satellite observation. Some products span almost 30 years. This satellite imagery can be rendered in your own web client or GIS application. Also underway is a NASA Earth Data group for collaborating and making discoverable Arcgis Web Services that allow for visualization and analysis capabilities. The group is crafting mashups and applications utilizing content for participating data centers, all driven by the user community. The goal is to have these services easily accessible in GIS clients, and allow end users to not only see the imagery, but also interact with the underlying data. These enhanced web services would allow for the analytic functions seen in the previous slide to be executed, and allow users to also integrate their own data without ever having to download or manipulate files. This group is also creating other resources such as Jupyter Notebooks and registering content on the ArcGIS Living Atlas of the World. NASA Earth Science has also created some really great web applications, inviting users to see data in a whole new way. The Power Data Access Viewer and State of the Oceans Viewer provide a window into our complex world. These user-friendly applications allow users to interact with the data, customize a map, add data, share the images, and most importantly, provide information about the data itself, linking you back to the source to understand the content you're seeing. There are also open data sites which integrate more than just geospatial content and can help add context to popular issues. These sites organize people, data, and tools to accomplish initiatives and goals. Web applications are also being deployed to support critical events such as natural disasters, providing new, unique ways to explore and visualize data. Earth observations can add immense value during disasters for those supporting response from far away or when conditions on the ground are not favorable. Web applications are also a great way to engage the general public. Here are two examples. One where NASA Data and Technology is providing global COVID-19 data, while the other is seeking input to collect data from citizens located near a NASA center. Another great example of using GIS to help make NASA data more digestible are story maps. Story maps are immersive stories combining a narrative with interactive maps and other multimedia content. These are great ways to showcase projects, highlight amazing science in an easy-to-understand way, allowing you to reach new, not-so-scientific communities. All of this content is helping to advance the use of NASA data, but we need to make sure it can be easily discovered in order to reach new communities. NASA establishes an Arcgis Online portal for public content such as services, maps, apps, and even notebooks. We're also working with the open data channels to ensure that content will be available through the Federal Geo platform. In addition, we're nominating authoritative content to the Living Atlas of the World, which is a global repository of foundation data. Digging in a bit more, NASA AGOL provides the capability to create and share data with the public and interagency partners by bringing data to end users in an easy-to-use, cloud-based web platform. Content on AGOL includes maps, layers, applications, tools, story maps, and notebooks. AGOL also allows us to establish trusted digital relationships to create collaborations with external partners. The Geo platform is an online centralized portal to share open, trusted, and nationally consistent geospatial content for use by the public, embodying the principles and spirit of open government and emphasizes communication, accountability, and transparency. It is a shared federal space representing communities across a variety of key themes such as climate and weather, geology, land use, soils, and utilities. The Living Atlas of the World is the foremost collection of geographic information from around the globe. It's a library of ready-to-use maps, imagery, and content for the entire world. Living Atlas promotes content to a huge audience and allows for easier discovery and harvest of existing content. Searching the atlas, you'll find NASA data, which includes sea surface temperature, chlorophyll concentrations, human population, hydrology datasets such as snowpack, precipitation, soil moisture, and meteorology and solar data from the Power Project. To help users get started, we've created a few resources. An Earth Data Learn GIS site, as well as an Earth Data Wiki space, provide guides and resources to help get started using GIS. We also have webinars that showcase the art of the possible of using GIS to enhance capabilities. Also mentioned previously in this workshop are data Pathfinders. A new Pathfinder specific to GIS was recently released, which was designed to help guide users through using NASA data in primary GIS tools. If you're interested in using NASA data, we'd love to hear from you. Your feedback is valuable in helping us work towards our mission of making NASA data open, accessible, usable, and useful to you. You can add feedback by going to the Earth Data site and submitting your content there. We'd also love to hear your thoughts on this specific session, so please submit the quick survey located on our webpage. Thank you again for your time today. We appreciate you tuning in.